Right. Okay, let's discuss these questions. So these are the theory questions. I think these questions are very easy, but sometimes a bit tricky as well. Oh, I haven't published it yet. Oh, really? Just give me one sec. Sorry. Are you sure? Okay. Let me let me check. Ah, yes. Week 10, week 11. I haven't published what I have done. Okay. Sorry, guys. It's my mistake. Okay. Can you check now? Can you please check whether it has been published? I have published it. Yeah, it's there. All right. Okay. My apologies for that. Okay. I think I made a mistake. I may have pressed that button yesterday, and I don't know, for some reason it may have not gone through. Sorry about it. Okay. Okay. So let's go through these questions. All right. So these are the theory questions. So let's read these questions and let's answer these questions. Now these questions looks very easy, but sometimes be tricky as well. Right. So the first question is, what roles does the entity relationship diagram play in the database design process? So if you get this kind of an answer, how are you going to this kind of a question? How are you going to answer this question? Right. What is the role? What does the role the entity relationship diagram actually plays in the database design process? Right. So database design process, it's a database design. It's another kind of a project in any IT project, right? Database is a separate project, I would say, right? So we can say a completed entity relationship diagram. Probably, or we can actually say it's actually a blueprint of the database, right? So its composition must reflect the organization's operations accurately as possible, isn't it? That's what we are trying to. So we are trying to capture the business rules, right? So business rules represent the organization's operations. Obviously, that operation actually give you kind of an idea, the data requirement for that particular context, right? That's what we are trying to capture. That's what we're trying to represent in our entity relationship diagram. So that's one of the key, I guess, a role that database or ER diagram actually plays, right? And also it also forms a kind of a basis for the final check on whether the included entities in our ER diagrams are appropriate and sufficient, right? In terms of number of attributes, or in terms of the relationships between different objects. So all these kind of checkings or final checkings can be done by going through this so-called blueprint or OER diagram, right? So sufficiency and appropriateness of attributes and relationships can be actually cross-checked by going through this blueprint or this entity relationship diagram, and that's actually one of the key second role, I would say, plays in the ER diagram in database development process. And also we can actually do a kind of a final cross check against the proposed data dictionary entries as well, right? So obviously when you develop the ER diagram, we can actually expect the data dictionary items that we will going to create in the database, right? And then the data dictionaries, actually we are not supposed, and when you actually come to the my other unit in the second semester, this next semester, you will learn actually we are actually creating some other data dictionary items alongside with the database as well, right? So we can actually use this blueprint or ER diagram as a kind of a cross-checking the proposed data dictionary we are going to actually construct in our application development environment, right? That's a kind of another role that ER diagram plays, right? And also one of the key role that ER diagram actually we use actually to communicate. I mean, database designers probably regularly communicate more precisely the details about the context and the objects and the attributes with the other stakeholders in the project, right? So for that reason, we need this kind of a completed nice blueprint about the database, so we can obviously communicate without having any issues with our other stakeholders in the project, right? Uh, um, and then finally, this ER diagram also actually play a very key role when it comes to implementing the actual database, because it actually give a kind of a guideline for database implementers, or those who are actually writing the code, that they can actually get this as a sort of a guideline to design the database and then they implement any constraints associated with any business rules, right? So we learn these type of things, right? So obviously these are the things probably will kind of the database, I mean entity relationship diagram actually plays when it comes to database design process. It reflects the organization's operations. It forms the basis for the final cross-checking, right, of relationships and attributes. And it also plays cross-checking against the proposed data dictionary entries, right? And obviously can be used as a communication tool with other key stakeholders, and also obviously it can serve as an implementation guide, right? So if you can kind of discuss these four things or four key aspects, probably you will get a sort of a full marks for this kind of a question. Okay, did you understand that question, guys? Are you clear about that? The reason why we create the entity relationship diagram, right? So what are the roles it plays in database design process, right? So are you all okay with that answer? The answer? Yeah. Does it sounds okay? Do you need any explanation or anything? Just let me know. Okay. Okay. I think that's pretty much straightforward. Okay. We learned those stuff, but putting everything into one answer is something that we struggle sometimes. Okay. Right. So that's the answer to the question number one. I think now we can move into the question number two. Right, now question number two also we already knows the answers, but how are we going to explain that? That's the problem, right? So what is the weak entity? So the question is asking, what is the weak entity and when is it used? How are you going to actually answer this kind of question? What do you mean by the weak entity? What does the weak entity means? And when we are going to use that weak entities? So are you going to answer that one? So what do you mean by weak entity? Weak entity is generally used to transform what? Many-to-many relationships, isn't it? Transform the many-to-many relationships into one-to-many relationship. Why we can't actually implement many-to-many relationship sort of a context in a structured databases, right? So for that reason, we need to transform these many-to-many relationship between two objects into two one-to-many relationship by using a weak entity, right? So weak entities, we sometimes call these weak entities as intersection entity. Remember that I have used that term as well. And then these weak entities usually has a primary key composed of multiple attributes. Obviously, weak entities need to borrow some of it or most of it primary keys from other related entities. Once it transforms, we need to obviously borrow one or two or maybe more attributes as a part of the primary key, right? That's one of the key characteristic of an weak entity, right? So we can say the primary key attribute actually inherited from the other related entities to the weak entity, right? So that's one of the key thing about the weak entity, right? So basically, weak entities we are using to transform the relationship, many-to-many relationship into one-to-many relationship. That's one of the key part of the weak entity, right? So if you can actually write that kind of answer in your own words, probably you will get good marks or 5 full marks for that. Or maybe you can actually give a kind of a example as well. Remember the examples. You can actually give many examples how you're going to transform into a relationship. So one of the classic example we have learned throughout our semester is movies and actors. Remember the actors movies. When we have an interaction between movies and actors, we have a casting weak entity in the middle, right? In the casting weak entity, we actually record which actor casted in which movie is presented, right? So we have actor number and the movie number. We borrows into the casting entity. Remember, we have discussed such a kind of sort of scenario throughout the semester. Or maybe you can actually think about some other scenarios, like we have subjects, we have students, students are enrolled in the subjects, right? Obviously, we can have another weak entity in the middle, sub enrollment, right? That's a very primary, preliminary kind of thing, but we have extended that with enrollment later on by having another weak entity created, right? Remember, we have subject and then subject offering, and students are enrolled in the subject. In that case, we have two weak entities in the middle, right? You don't need to actually go into such detail in this question. Maybe give a kind of a simple example: movies, actors, and then we have casting weak entity in the middle. That's it, right? So you don't need to go through with big complex kind of expansion, sort of transformation, sort of relationship like subjects and the enrollment, right? But that context is quite different. But you don't need to go that such far to answer this question, right? So if you can give a sort of a very small, a very straightforward, small, uncomplicated, I mean, example, I think that's enough, right? That's enough. What I want in this kind of question is your explanation why we need weak entities and how the weak entity determines its primary key. So if you can answer these two, probably you get kind of a full marks for this kind of question. All right. Right. So any questions so far? You guys okay with the answer to the question number 2? I think it's very straightforward. Right? Are you okay? Okay. Right. Right. So all good. Okay. So how about question number 3? Question number 3. Question number 3. What are the two conditions must be met before an entity can be classified as a weak entity? Right. Did we learn this thing? We may have learned this thing, but probably we know already. But what are the two conditions that you can actually think about that we can classify an entity as a weak entity? And then it asks, give an example of a weak entity. I have already given you an example of a weak entity, right? Movies, actors, and the casting weak entity, right? So we have two strong entities, movie and the actor, and then we have casting weak entity in the middle, right? So what are the two conditions must be met before an entity can be classified as a weak entity? So to classify it as a weak entity, yeah, so that's right. Yes, you are correct. So the first condition is entity must be existence dependent on its parent entity. Remember, that's one of the key content, right? Because weak entity must be dependent on its parent entity, right? So the casting entity actually depends on the movies and the actors entity, right? Otherwise it won't, it can't stand by itself, right? That's existent dependence, right? So that's one of the major, I would say, one of the main condition that you need to satisfy to make a weak entity, right? Existent dependence, right? And then, as Shay is said, the entity must inherit at least part of its primary key from its parent entity, right? Part of its primary key, right? Sometimes it inherits the whole primary keys from its related parent entities, but sometimes the part of it will inherit from the parent entity, right? So the two conditions are: the first condition is the entity must be existent dependent on its parent entity. The second condition is the entity must inherit at least part of its primary key from its parent entity. So if you can actually just list these two conditions with an example, you can give the same example which we have discussed before, two parent entities, movies and the actors, and then one weak entity in the middle, the casting entity, right? And then that's enough. You will get a kind of full marks for this question, right? Okay. So that's the two conditions. Okay. I think that's answer for question 3. Very straightforward. Okay. Question. Right. How about question number 4? Okay, now we are moving into right now. What is this one actually? We may have not actually learned this. What is a strong or identifying relation? Sometimes when we have a relationship between the weak entity and the strong entity, we can call it as a strong relationship or identifying relationship, right? And it says how we going to depict it in the interrelationship diagram, right? So if you have a kind of if a strong relationship exists, we can say a strong relationship exists when an entity is existent dependent on another entity, right? And inherits inherits at least part of its primary key from that entity, right? So in that case, we can call it as a strong relationship. Okay. Yes, as Karin mentioned, how we're going to show that in our ERD diagram, we need to underline the relationship with the solid line. Okay, solid line. So that's how we are going to show it, right? So we can say the strong relationship exists when the weak entity is related to the parent entity, right? That's how we show it in the ERD. Okay, so always the weak entity has an existence dependent on its parent entity, or we can say the another entity. So, and then obviously it inherits at least part of its primary key, or the whole primary key from its inherited or dependent entity, right? So that's how we determine the weak entity, right? And then obviously we underline the relationship, right, to show to indicate that we are borrowing the primary key from the other related entity. Okay. Right, so that's the answer to this last question. I guess that's obviously you know that how you, so the thing is how you're going to put into the words, right? That's a challenge. So that's how you're going to answer that question. Okay. So if you can write it in your own words, you should be able to get the full marks. Right, so that's the answer. Now let's go to the question number 5. Do you have any questions so far for related to the first 4 questions? Looks like, okay. I think these 4 questions related to the theory so far we have learned in this semester. All right, so let's move to the question number 5. Okay, question number 5. Right, so they have given a table. Okay, now let's go through this. Given the business rule, an employee may have many degrees, right? Okay, now there's a business rule called an employee may have many degrees. Discuss its effect on the attributes, entities, and the relationship. Okay, now they have given this table, right? So you can see this table here. We have employee numbers, right? Employee last names. So L name is last name, okay, and then the degrees, right? Different degrees each of the employees have been received, right? So so you need to discuss its effect, right? So you can see that when you go through this sort of this table, of course you can see kind of it's actually not a design flow, but you can see here in the third column, it looks like there may be a multiple values exist, right? Yes, not multiple attribute kind, it's multiple values, isn't it? We have one attribute, but with the multiple values in each row. Yeah. But it's can we have this sort of, I mean, we have learned that in our what do you call this last week, the normalization. It's obviously we not supposed to keep this sort of multiple attributes, but if you want, you can keep it, right? If you want, you can keep it. How can we keep a multiple multiple? Well, we can actually record this as a string, isn't it? Right? As a string, it's okay. We can have a varchar kind of the big string. We can put multiple values and put commas and separated each. Well, that's obviously okay. We can do that, but obviously it's not a kind of a good thing to do. Because the reason is if you keep this as a long string, then of course you need to do kind of a string. You need to actually implement some kind of in-string search functions in your queries. Okay, for example, if someone wanted to find out how many degrees an employee has been received, then of course they need to actually write a query with a string function on it, right? So what are the string function? We will, like, did I teach you, or probably this week lecture you will learn the recorded lecture, by the way, you will learn the string functions. So how are you going to use the string functions or in string functions to search and find some values in a big string, right? Obviously if you implement that sort of another kind of a string kind of other functions on top of normal queries, probably our queries probably get more complicated and complicated. And one of the key thing that we are trying to actually achieve in any queries in SQL, try to guys make sure that we simplifying the queries, right? Query simplicity is a valuable thing to application developer, right? Don't be complicated with cumbersome solutions like putting in string function and then running a kind of aggregate function on top of that to count the number of degrees. That's kind of not a query simplification, right? And obviously the end users of the application obviously need maximum query execution speeds, right? So we don't, now imagine we have millions of rows, it matters, right? Query execution time. So probably, so that means this might not be a best solution in that case, isn't it? Because obviously we need to put sort of in string functions to extract these values in these strings, right? So that means execution speed of the queries obviously probably goes down. Or sometimes maybe another person maybe come up with another solution to this problem. Maybe they may say, okay, we can have multiple instances or multiple values as a even string. It's not good to keep, and we learned that in our normalization, right? It's not a good thing to do, but we can do that. It's okay. We can record it as a string, but it's not a good thing to do. But then another person can come and design a table like this. Say, for example, let me actually design a table. It may not be a big good table. Okay, so just excuse with me. So I may have employee number, right? We may have employee number here. Actually what I will do is rather than having this, let me actually open Excel spreadsheet. It's easier for me to actually then write rather than having this one. Yep. Okay, so someone can actually design a table like this. They can have emp number in a one column, and then they come up with maybe then emp. So what is the next column? Sorry, I just where is the emp last name, right? Emp last name or L name, and then they may come up with, okay, so you can see in this in here each employee can have now in this case, so we may have different degrees, right? So here the second employee 124, here she or he actually receives 4 degrees, a BBA, MBA, and PhD. So we can, someone can actually design a can think, okay, why not we have a 3 columns? Okay, this is my M degree 1. Okay, M degree 1. Then this is my M degree 2, right? And it's my M degree 3 column, right? So someone can actually design a table like this, right? And then, for example, maybe can say employee number 123, Carter. Maybe he may get a kind of a BBA degree, and then got a kind of a PhD as well. And then here it's a null value, right? There's no second degree or degree 2, or maybe put a kind of a PhD here, sorry. And there is not a third degree, maybe we can put null. And the employee number, say 124. We may have say Jones or somebody like that can have only 1 degree, so BICT, and then they don't have any 2 degree, he or she doesn't have any 2 degrees, so null and null. So likewise, they can come up with this sort of solution, isn't it? That's also possible, right? That's also possible compared to this solution, right? So then obviously we can overcome this problem having multiple instances or multiple values in a single column. Then obviously again, then we need to question that, is this the best solution as well, right? Is this the best solution as well? Then somebody can question, no, not probably. It's not a big problem, because you can see there are kind of many null values, right? Null values. Remember the null, when you have multiple null values, then obviously it's not a good solution as well. Null create issues in database solution, databases. And then the other problem in this case is, for example, in this here we have a maximum three degrees. Right now, obviously, another person, if you think, right, another person maybe earn 4 degrees. What will happen if in that case? Then what we need to actually, we will overcomplicate our existing database. What we need to do in that case is we need to completely redesign the structure. We need to actually add another column, right, to the table. That is also possible. Then need to overcomplicate it as well, right? This solution, right? So I would say this kind of a solution is also not a kind of a perfect solution. Solution for this sort of a problem, right? So obviously we have overcome the issue of multiple values, but again, then this solution have another issue like multiple null values, plus what will happen if another employee earn a 4th degree or 5th degree or 6th degree, then we need to have multiple another columns has to be created. That's another issue, right? Then another person can, okay, that's a problem. Okay, so if that is the case, why can't we have a solution like this? We can have a number in a one column and a last name in another column, and then why can't we having indicating M degree 1, M degree 2, M degree 3 like that? Why don't we actually put the real degree names in each column? Like, this is my BBA degree column, this is my BICT degree column, this is maybe Bachelor of Information System degree column, this is my PhD degree column, right? So somebody can actually come up with this sort of a solution as well, right? That's also possible. For example, employee number 123, number Carter, we can say he earns a BBA degree. So he's saying, okay, we can put yes for the BBA, and also the PhD. Then we can put yes for the PhD as well. And then actually now you can see in this kind of solution, the null actually we have more and more nulls, isn't it? Right? So it will create more and more nulls. Here, in this case, we have only one null in this row, but now when you have this sort of a solution, the null values maybe increases as well, and that means this solution is also not a kind of a obviously a better best solution, I would say. So obviously these two solutions, probably solution as an alternative for this solution is not obvious as well. Then what is the solution? Then what is the best solution that we can actually implement in this case? That's another question, right? So what we can say in this case is to simplifying the query, what we can do, we can actually go through this structure and see what sort of what they are trying to actually tell in this case, right? So you can see we have a employee related details or employee related information here, and also degree related information. So why don't we create two separate tables, right? One for the employee, one for the degrees, right? So somebody can, if a person who did a database with me, simple, and obviously you can think, okay, why don't we create a solution like this? Okay, let's have a entity for a degree and another entity for say employees, right? Something like that. Okay. So I just put the empty. So for the for the employee, we can have emp number, right, in a one column, and then employee last name in another column, right? That's my first table, and then we can have another table listing the degrees, right? So we can have a for example, we can actually, in this case, we can think about like this. We can have we can actually take employee number here, emp number, and then we can have say degree code, right? For example, employee number 123, degree code BBA, right? And then we can have a other information related to degree, right? So degree, maybe date, and the description of whatever the any column related to, so we can add more and more, right? So in this case, is this solution better solution compared to the other? Yes, of course, definitely. So we have now two separate tables. One is employee table, which has employee details, and then the second table, which contains the degree layer, so employee number. Or maybe we can actually think about this as a weak entity as well, one to many weak entities. So one employee can have many degrees, right? So employee number we borrowed, degree code is there, and a degree date is there. So we can actually take these three columns as a composite identifiers, right? Isn't it? Composite identifiers, and make a as a weak entity, right? So one to many. Okay, so one to many. So we can actually do that as well. That's definitely okay, because sometimes an employee can have same for some weird reason. Sometimes they can get two degrees, the same two degrees, right? Maybe maybe if one employee may have done the degree maybe 10 years ago, and he think, okay, it's outdated, I need to redo this again, maybe do the same degree again, right? And then if you combine it with the degree date, degree code, employee number, and the degree date, obviously that may be a perfect primary key for this entity, right? So one to many, right? So this solution is obviously okay, I would say. Obviously okay, it works, right? And then the other solution, probably the next solution, probably as we all knows, we all familiar with, we can have two tables like here, employee table and copy. I just copy employee table, and then we can have a table called a degree table, right? So let me write here the degree table. In that degree table, we have maybe you can have degree code and all these things like degree description, um, etc., etc. So more details regarding degrees we can keep in a separate table, and then obviously we can link these two, right? So this is the primary key and number in here, and degree code is the primary key for the degree table. So we can actually then think about, okay, we have multiple measurement relationship between these two strong entities, right? One employee can have many degrees, and one degree can be earned by multiple employees. So obviously we can have a weak entity in the middle, right? So that weak entity is where we record all these so that weak entity, the primary key is emp number, and the degree code and degree date comes there, right? And then it actually record which employee got which degrees at which date, right? And probably which institution or what, etc., etc. So that details can be recorded there as well. So that's the second alternative to this the first one as I discussed before, right? Right. So that's what we need to actually tell here in this case. Now, obviously, this query, the answer is bit long, so you can actually explain these things as an answer to this question, right? So remember, even this solution is okay, right? This solution is okay as long as we keep this as a string value. It's okay, but I would say this is not that efficient or effective solution for a database, as I mentioned before, right? Because efficiency is very important. Query execution time or speed is very important when you write the queries for the databases, right? Right. So that's the answer to this question. Does it make sense, guys? Does it make sense how I explained that? Okay. Right. Let me know your do you, yeah. So do you need any if you need anything, just let me know, right? Or maybe you can rewatch the video again. Okay. Right. So now see a small problem, small. It looks very simple, but there can be so many. So there are different ways that we can implement things, right? Then there can be different problems can arise depending on the solution that we suggest, right? So that's how you need to do, right? Now these things, guys, I don't think it's you need to come with the practice. Sometimes I learn those things from the practice as well. It's really hard to teach these small bit and pieces sometimes. Okay, so when you Tarin, how do you write the answer? You can explain that. Maybe you can give first. Okay, we can give a kind of obviously what is the design issue in this kind of solution, right? Multiple instances in a third column, right? You can keep, but that means you can actually still record that as a string value. That's obviously okay, but this is not a very good design, as it will take much time to execute the queries, because we need to do a string manipulation or string function. We need to implement string functions because to extract some information in a string value, right? So therefore we can suggest a better solution. Maybe you can actually, rather than explaining these things, right? I just explain these things for your knowledge. Maybe you can actually go directly to the solution here. One of these solution, this one, or maybe this solution, right? So that's enough. I am not expecting you to write pages and pages. I just explain you a little bit more in detail for your knowledge. Okay. Yeah. Okay. So Shay, sorry, I just missed your. I think you mainly need to explain how the ERD database should be function. I think yeah, that's right. Yeah. uh, that's all. I don't need actually bit of if you can provide a small table like this, that's much better. Or maybe what you can do is you can actually design an ERD in your answer. That's perfectly okay. You can say, okay, why can't we have ERD like this, right? So we have employee entity, and we can have a degree entity, right? And then we can have a week entity in middle, where it shows which degrees earned by which employees. So that's enough, right? So that's the alternative number one. Or the second alternative, sorry, this is alternative number two. The first alternative is this one. As I mentioned before, we can have uh, um, employee table, and we can have a weak entity here called the degree table. In this case, it's a weak entity. Um, Sorry, weak entity, and we borrows the employee number, right? And then we have its own uh, attributes as part of the primary key. This is the date of the degree, and what else? And then the degree code. So this is degree code, and this is date the degree has been earned, right? So you can suggest this solution or maybe this solution. Okay, this is first alternative. This is second alternative. This is what we have learned, right? This kind of alternative. So this is, I believe, it depends on what sort of information the company is looking at. If the company is wanted to keep more details about the degrees, I would say suggest this one is much better, because we can add more and more columns later on related to the qualifications. That company like to keep regarding the specific degrees that employees earn, right? This solution probably is not that bad. This is okay, I would say. In this case, probably you may actually limit the number of information you can keep, because each row represent each employee's qualification, right? So therefore, having more and more information probably lead to more redundancies, right? So it depends on the company's organization's intention, right? If the organization says, oh no, we don't want to keep much more information regarding degrees or the earning qualification, obviously then we can suggest this one. That's okay. But if the company says, no, we use the employee learning, as a promotions, and so we need more and more details regarding their learnings, right? And then we can actually suggest this solution, right? It depends, right? So as a consultant, as a database professional, you should be able to explore these sort of alternative and suggest different models. That's obviously one of the lessons we are learning in this subject, isn't it? Yeah. Right. So okay, so that's the YouTube says all the MBA situation with the one-to-many, but you started, it's been better to make any with the interaction. Yeah, that's another one. Yeah, so this is one of the, but it depends on the company's the organization's objective, Thomas. Okay, so this is one of the this is actually I preferred personally, but this solution also not too bad, depending on the situation, right? We can suggest, because when you create more and more, of course, more and more table, then the maintenance issues also come into play, right? So some developers or some project managers actually they don't really like, they actually like to have more table, because then if in future if you wanted to redeploy, some, so maybe they may think, okay, man, we need to save our job also, right? So less complicated is much better. So they may come up with this solution, and then later they can suggest, okay, why don't we go for this solution, because then they can have another newly, if they can create a new project initially, and they can keep their jobs more and more. Yes, that kind of things happen in the real life, right? So we'll learn this stuff when you go to the actual projects. Yeah. All right. That's the answer for that question, this question. Okay. Right. Okay. All good so far, guys? Are you happy with the answers? Yeah. Let me know. Okay. Right. Okay. How about question number 6? Question number 6. Question 6. What is this question 6 is asking us to do? Right, so question 6. Suppose you are working with the framework of the database model below. They have given a model now for us, right? Looks like, okay, so it looks like a bunch of strong entities. Now what they're asking us to do, the part A, right? The business rules that are reflected in what they're doing is they're asking us to reverse engineering this model, right? So far what we have learned, they have given the business rules. We model the model the ERT, right? But this time they gave the ERT. We want to reverse engineer and find out what are the business rules hidden in this sort of environment, right? So how do we write the business rules, right? So that's that's and then when you kind of you can have this sort of question, probably make sure that each business rule is written in on a separate line, and then it can easily spell it out, right? So don't try to put everything in one paragraph, okay? So Tarin, yes, is something, yeah, so yeah, that's what we want in this case, right? Now let's go through this. So what are the business rules? We can obviously see in this, so you know what do you mean by the business rule, right? So business rule usually we derive from a carefully and precisely written description of the business operations, right? When you write the business operations, when you know context that we are trying to develop the business, the database. If you write the business operations, so we can derive the rules governing these business operations to reflect on our ER diagram or the model that we are trying to implement. Okay, right. So let's and also it's asking us to identify all the cardinalities. So let's go through this. So let's go through one by one. So the first thing is now what it looks like actually. What is the context? It looks like kind of a repair or maintenance sort of vehicle repair or something like that, a garage, something like that, isn't it? Right, so we have customers in the cars. So we first thing when you get kind of this kind of question, we just go through. I mean, don't try to read these things, just try to visualize what's there. So we have customers, looks like vehicles or cars are there, looks like there are many cars for one customers, right? And then they have the maintenance sort of records with the cars, right? And then there are parts, and then each maintenance looks like using different parts. That's what they mean by maintenance lines. So why they have this? Now it looks like all are strong entities, so that means each one may have kind of an ID, its own ID, right? Customer may have custom ID, car may have a car registration number as the primary key, maintenance may have maintenance ID or something like that, and then the parts obviously may have parts ID, right? And then the maintenance line have maintenance line ID as well, right? So let's go through the business rules now. Right now looks like now remember when you go through the business rule, we can capture that in both directions, right? So let's go to the first relationship between the customers and the cars. A customer can own many cars. That's what it looks like, right? One customer can own many cars, right? Yeah, that's obvious. And then what do you mean by that? One customer may own many cars means there can be some customer that do not own cars as well. We can have customers, probably they may have sold They are vehicles, but still we listed as a customer. That's why it means by may, right? So one customer may owns many cars. That means we can have customers without vehicles as well. Yes, yes, that's Thomas. You are right. So customer can own zero or many cars. Yeah, that's what we mean by that, right? And then if you think about the other direction, a car is owned by one and only one customer, right? If you have a vehicle, that vehicle belongs to one and only one customer. That means one vehicle can't be shared by multiple customers. That's what we mean by the right to left direction means, right? So there are three business rules in this case, right? The customer can own many cars, right? Some customers do not own cars, right? A car is owned by one and only one customer, right? So obviously there are three business, or maybe you can say one customer can own zero or many cars, and each car is owned by one customer. That's also right, as Thomas pointed out, right? That's also okay. And then the maintenance records, right? Also the maintenance. Um, a car may generate one or more maintenance records, isn't it? That's what we mean by a car can be on zero or many, sorry, not one. A car may be generate zero or many maintenance records, right? Um, and then each maintenance record must belongs to one vehicle, right? Because we may have some cars that generate no maintenance records so far, maybe the brand new vehicles. They may not have any maintenance records so far here as well, right? So that's perfectly okay, right? Um, that's perfectly okay. So that's that relationship. Um, and then we have this relationship looks like now we have maintenance procedures, right? So maintenance procedures use many parts. That's what we mean by this, right? So we have maintenance procedures used by parts. So if you have one maintenance, if you have maintenance procedure, each maintenance procedure can use many parts, right? So this is what we recording here, right? May use many parts. Can use many parts. Can use many parts. So we can have maintenance procedures may include, say, multiple maintenance actions, right? For each one which may or may not be use any parts as well. For example, some maintenance procedure like say a 10,000 mile or kilometers check may include the installation of oil filters as well as air filters, right? So that obviously need new filters, right? So we need parts, but sometimes some maintenance procedures probably may not require any parts as well. For example, if you want to tighten the alternator belt, right, it does not require any part, but it's still a maintenance procedure. So that's what we mean by this may, right? So some parts may be used by maintenance, or maybe we may not have any main parts used by at all for the maintenance procedures, right? So that's what we mean by that. And then each maintenance procedure generates one or more maintenance. Each maintenance procedure may generate one or many maintenance lines, right, or maintenance actions or whatever, right? One or many. If you have a maintenance procedure listed in our database, it has to have at least one or many line of action, right? Maybe changing oil filters, or fixing or tightening the these sort of belts, alternator belts, right? Or maybe repairing some damaged part, etc. So that you can have at least one or many maintenance line procedures. That's what we mean by this, right? And each part, and then if you have if you have a maintenance line, it may, if you use a part, part must belongs to the part entity as well. That's what we mean by that, right? So sometimes each part may not require for the maintenance line, but if you use the part, it must belongs to one of these part categories in our database. That's what it means, right? So that's actually the meaning of that's how you describe the business rule in this case, right? So we can actually grab probably maybe 9 or 10 business rule from this model, right? Cardinality actually tell you how many instances, how many times it appears, Thomas, in the other times, how one instance related to other instance, how many times. So here you can see one customer can own zero or many cars. So that means one customer ID can appear multiple times in the vehicle entity, right? So that's what I mean by the cardinality. How many times it can relate with the other instance in the other entity, right? Or in other words, how the parent entity and the child entity relate, right? How many times, or how, is that many, or once, or zero? Okay, that's what we mean by the cardinality. Okay, right. Does it make sense, Thomas? Yeah. Okay. Right. So the question, that's the question. I think it's straightforward. You can actually, left to right, right to left, go through that. Then you can have maybe 7 or 9 around business rules in this case. Right. That's the answer to question number 6. Any questions so far, guys? Are you okay with question 6? Shall we jump to question number 7? Am I too fast? No? Yeah. All right. All right. Okay. So what is this one? Question 7. Discuss the difference between. All right. Now we are coming into a theory. Discuss the difference between the composite key and a composite attribute. Okay. So how would each be indicated in an ARD? So what do you mean by composite key and the composite attribute? How are you going to distinguish this? Looks like same, right? Isn't it? Look at it, it's the same. No, actually it's 2 different things. Composite key, you know the composite key means, right? You know the composite key, right? Composite key is what? Composite key is one that consists of more than one attribute, right? So if the ER diagram contains an attribute names for each of the entities, a composite key is indicated in the ER diagram by we underline the attributes, right? For example, if you have a weak it's not even the weak entity. If you think about strong entity that can have composite keys, right? So if you have multiple columns composing, I mean contributing to primary key, then that is called the composite key, right? So obviously in the weak entities we have the composite keys. That means even in the strong entities we can have the composite key as well. Sometimes we need to combine 1 or 2 columns to make it as a primary key, right? So that's what we mean by the composite key. So the composite attribute means is the attribute consists of multiple or the attribute consists of multiple I would say multiple other attributes. For example, if you think about, now we can't show the composite attributes or composite attribute in ERD diagram. For example, if you think about attribute called a name, right? For example, employee, we have an attribute called name. The attribute name probably a composite attribute. Why? It can consist of multiple values. For example, it can have the initial, then the first name and the last name and the middle name, right? So that's called the composite attribute, right? It can have multiple values. And then obviously the address. Remember, the address can have a composite values as well, right? It's a composite attribute. We can have a street number, street name, right, suburb, then the area code, etc., etc. So that's a composite attribute. So that's what we mean by the attribute. So when you design the databases, it depends on whether the company, the organization wanted to separate the composite attributes to separate attribute or keep it as a composite attribute. It depends, right? Depends on the context, depends on the management requirement, depends on the report requirement, etc., etc., right? So how do we indicate then in ERD composite attributes? We can't indicate in the ERD, right? So if we just indicate it, okay, if it is a name, we just put a lollipop saying, okay, that's the name. If it's an address, we just put a lollipop call, that's the address, right? But when we implementing, when you write the queries, probably it might be a very big string, right? Employee name may be big string, right? Or address may be a big string or varchar, right? So you need to think about, do we really need the composite attribute, or just we need to break down the attribute into smaller parts rather than keeping a composite attribute. Okay, right. So that's the difference between, that's the distinction between the composite key and the composite attribute. You guys okay? Does it make sense, guys? Does it make sense? The key difference between the composite key and the composite attribute, right? Right. Okay. Right. So that's the answer to question number. Am I too fast, by the way? Sorry. You guys okay, right? So anyway, it's recording. So if you want to revisit, you can revisit it. And then yeah, if you need any clarification, please send me an email. I actually prefer to post your questions in discussion forum, so everybody can participate in the discussion. I can participate, your colleagues can participate, so let's make it as a kind of a really good place for us to interact. Okay, right. Okay. Yes, so as Tarin mentioned, yes, composite attribute we cannot implement, we cannot show it in ERD, by the way, right? Thomas, not the Slack, it's inside our canvas. Unfortunately, Slack is not supported by Swinburne. That's something, you know. If you go to our canvas, we would see the discussion forum here somewhere. Let me show it. Do we have discussion? Yeah, somewhere here. You can see here. You can see kind of, I just put, you know, test 2 discussion, test 1 discussion, etc., etc. Maybe you can post your question there, test 2 discussion, right? So you have, I mean, I actually encourage other students to visit there and then contribute. And if you know the answers for some answers, just contribute to your colleagues, right? And I also contribute. Okay. Yeah. So that's the place. But yeah, so I think most of you have not visited. I also, you know, I went through it, but I haven't seen much. So just put your answers, questions there. I actually encourage people to. This is the main actually discussion. This is the forum. This is where mainly we offline discuss our stuff. So use this as maximum as possible, guys. So it's rather than, you know, so everybody can see the answers, common questions and answers. Okay. Right. Okay, now we are in question number, all right, question number 8. Question 8. Now how are we going to answer that question? What is a derived attribute? Give an example. What's the derived attribute? Give an example. What do you mean by the derived attribute? Have you heard about that term? I think I have explained that, right? One of the case studies. Remember, pizza delivery case study. Pizza delivery case. Glenfield Toy Library, pizza delivery week number, I think 5. This term has been discussed. Derived attribute. What do you mean by the derived attribute? Derived attribute is an attribute whose value is calculated or derived from other attribute, right? So for example, if I wanted to calculate employee's age, we can actually compute it by using algorithm, right? We compare it with the current date with the employee date of birth. So if we just have record the employee date of birth, in our database, we can actually calculate the employee's age, right? That attribute can be calculated by designing algorithm. Okay. Um, so the derived attribute need not to be physically stored within the database. So we usually don't store. Sometimes in some cases can be, right, depending on the management requirement, right? But in most cases, probably we are not going to store the derived attribute. We are not physically storing it, right? So because it can be derived using an algorithm by going through other attributes. So that's what we mean by the derived attribute. Okay. So an example is employee age, right? Can be derived by comparing the current date with the employee's date of birth in our table, right? So that's actually a kind of very direct answer. I guess that's very easy, right? Easy question. But obviously you need to know what's the term derived means. Okay. All right, that's the answer to question number 8. And now we are going to our favorite question. What's our favorite question, guys? Yeah, the question, isn't it? Right. Yeah, the question. Okay. What you can do here is, now they have given this one. Okay, so let's actually do this, right? Shall we do together, right? Yes, our favorite is ERD, right? Okay, now let's read this question. And now in the test also you'll get a kind of you will not going to get this kind of very complicated one. I'm not going to give you that, but you know how to do that, right? I don't want you to, I mean, if you want to use diagrams.net, that's okay if you're very comfortable, but not, you don't need. Maybe you can use the paint to draw a sketch, but make sure that when you write the answers in your test, make sure that it's bit, I don't mind, I mean, right, but kind of can read it, right? And then obviously if you want to write, underline something, make it clear, right? And then once you've done that, you can copy, can take the snipping tool, and then copy it like this, something like that, and then paste it to a Word document and then upload the solution. Okay, so that's how you need to do. Make sure that, guys, test 2, the last question is the ERD question. You need to be very, very careful when you're keeping the time, because I think it's a 90-minute, right? So when the time lapses, it will automatically shuts down the links and everything, and then you may miss to upload your the answer. So please make sure you upload the answer, because we are not supposed to. Now if you send me an email saying, okay, this is my answer, sorry, I forgot to upload, or it automatically shut down in the last minute, unfortunately that might not be a big proper issue. This problem for me to accept it, because the university is not encouraging us to do that. Okay, so make sure you keep the time, right? Make sure you keep the time, very close eye on the time, running in front, because otherwise I don't want it shut down and then you obviously panicking and send it to me the email. So please make sure, okay, for that. That's something you need to be very careful regarding test 2. Tarini, yes, I feel like I'm going to stick with the diagram software because okay, doing somehow. Okay, yeah, that's true. That's also true. But I like this freehand drawing. You know, when you're teaching this, I like this one. I think it should be okay. Yeah, for you guys, of course, definitely you should know how to use a professional software programs like diagrams.net, because you guys, when you go to the industry, you are communicating all these diagrams. You can't have kind of this sort of very rough one. Obviously, you can do a rough one in here, like, and then you translate into diagrams.net version, because obviously you are communicating it with other of your colleagues in the that project. You can't have kind of a shady kind of diagrams like this. Okay. All right, now let's come back to our favorite question. Okay, now let's go through this question and see how it goes, and then let's capture. Now let me actually, I just make a new, don't save, I don't want this one. Okay, so let's read the question. Okay, so United Brokers Artists, so UBA is a broker for not so famous painters. UBA maintains a small network database to track painters, paintings, and the galleries. A painting is okay, now actually this is two okay, so two questions. This is the first question. Okay. So network database attract multiple galleries. A painting is painted by the particular artist, and that painting is exhibited in the particular gallery. A gallery can be exhibit many paintings, but each painting can be exhibited in only one gallery. Okay. So there are a bunch of business rules there, isn't it? Similarly, a painting is painted by a single painter, but each painter can paint many paintings, right? Many paintings. Okay, so what tables would you create, and what would be the table components would be, right? Components, probably, what are the components? Maybe you need to tell, okay, what is the what are the possible attributes, and what are the possible primary keys in this case. So here we need to make an assumption sometimes, because when you go through this question, it's obviously not possible to track the attributes, some of the attributes, right? Especially the primary keys. And then what are the business rules that we should implement? Right, so let's actually, and then how might the independent tables be related to one another? Okay, so that means we need to show, if you can show it in a ER diagram, that would be fantastic. Then you can actually show how the tables are related to each other. Okay, now let's actually go through that question again. Let's actually draw a kind of a diagram to capture the database. So that will be easier for us. So United Brokers Artists is a broker for not-for-profit painters. Do we need any entity for the UBA, by the way, guys? Do we need an entity for UBA? Obviously, that's a kind of a that's a noun. Do we need that? No, right? We don't need that, because that's a company. That's the company organization we are wishing to implement the database. So we have only one instance, so we don't need any entity for the UBA, right? So there's, and then they're talking about not for painters, right? So UBA maintains a small network database to track the painters, paintings, and again, okay. So in this sentence, obviously, we are talking about three objects, right? Painters, paintings, and the gallery. So obviously, these are the three objects we need to capture. Yeah. Okay, so let's assume these are the three objects. So let's read the next line. A painting is painted by a particular artist. Okay, now let's go to our model, this one. So let's capture that. A painting is painted by a particular artist. Okay, so let me draw the painting. So that's my probably looks like an entity, right? Painting. Lord, I just put PA. This is my painting. So let's assume um, uh, this is my painter, right? So painter, let's say we have the painter number. So this is an assumption, okay? Painter number, right? So let's assume this is my primary key, or paint ID. Yes, that's right. So let's assume, okay, paint number or paint ID as the primary key, along with some other attributes. Like we may have some other attribute like painter's last name, painter's first name, painter's initials, etc., etc. Their address, right? So contact details, right? So all these information goes here, right? So they haven't actually specified this. So let's assume this goes there. A painting is painted by a particular artist. Okay, so that means painters can be paintings, right? So that means we have another entity So let me actually draw this one right here. So we may have another entity called painting, right? So let me actually capture that. uh, Painting, right? So painting, right? uh, so painting is painted by a particular artist, so that means obviously there is a relationship. So um, so one painter can paint, we can say one or many paintings, right? One or many paintings. Okay, let's assume that a painting painted by particular artist, and the painting is exhibited in a particular gallery, right? A painting is exhibited in a particular gallery, so that means looks like obviously there's a sort of another entities lurking somewhere here, isn't it? That's the gallery details, right? So we definitely need to capture the gallery details, right? So uh, probably can actually draw an entity here. You can say this is my gallery entity. So let's say gallery. And so we may have a, so let's actually assume in this case, um, since they have not given any sort of um, um, attributes, so let's assume this is a strong entity. Yeah. So let's assume this is my painting, maybe we can say painting number or something like that, right? Painting, I just put painting ID or something like that, right? Painting ID, that's the primary key, so it's a strong entity. That's perfectly okay. One too many, so there's a there is what do you call, foreign key sits there, right? So painter's ID is there, right? So that painting is belongs to this particular painter, right? That's perfectly okay. And the same applies here. So we have the galleries and the paintings, and there is a relationship between the galleries and paintings. So what is the relationship between gallery and gallery? Obviously it looks like one to many, yeah, because one gallery can actually exhibit multiple paintings. That's obvious. So it's many n has to come in this side, right? So let's assume we have a here the identifier of the primary key as gallery ID, something like that, GID. That's my identifier. So one gallery can exhibit one or many paintings. That's possible, right? That's possible. So let's read that a gallery can exhibit many paintings. Yes. Okay. So this says, sorry, a painting is painted by one particular artist, and the painter is exhibited in a particular gallery. Yes, that's true. Yes, and a gallery can exhibit many paintings. Yes, that's also true. But each painting can be exhibited in only on one gallery. What do you mean by that? But each painting can be exhibited on. That's what we mean by, okay. So if you have one painting that must belongs to one gallery, right? That must belongs to one and one only gallery, because you can't take that painting to another gallery and exhibit that, because they may have exclusive contract with that. The art is always saying, okay, if you have the painting, it must belongs to one gallery, right? So that's why I have a mandatory there. So relationship. So that painting must belong to one and one gallery represented in this table. So similarly, a painting is painted by a single painter. Yes, so one painting must belongs to a single painter. So that's there. But each painter can paint many paintings. That's okay. Yeah, so one painter can paint many paintings. It writes one or many paintings. That's also okay. I think that looks like this, isn't it? So and then we can have multiple other attributes here as well. For example, paintings, we may have painting titles, right? and other related painting, what is the materials used in the painting, etc., etc. We can have another attributes. So here we have now two foreign keys sits there, right? So painter's number or painter IDs comes there, and gallery ID comes there, and then painting, it has a painting ID, its own primary keys there, and together with other attributes. Okay, so obviously this is a possible solution. This is a possible solution. Or probably if you not read this correctly, maybe you may think about another alternative, right? So maybe some person can think, oh, why not we can have a solution like this? We can have the painter, right? So this is my paint ID. Sorry, just put sorry. So this is my paint entity, right? So paint ID is here, and why can't I create a weak entity between painting and paint, right? So that's another possible, right? So this is my painting entity. Sorry, painting entity. So just put painting, and then somebody can say, okay, sorry, so this is sorry, this yeah, so I take the painting, it's somewhere here. This is my painting entity, and then we can have kind of weak entity like painting, or we can actually give another name here. We can say paint a painting or something like that. Like paint a painting. So sometimes somebody can think about it in this way, right? So we have one to many, right? This is my painting entity. This is this one, right? So we have painting ID, and this is the paint ID, and here we have a we can borrow the primary keys. And this solution, I would say, not an ideal solution in this case, because it says in the business rule says one painting is actually belongs to one painter. There's no multiple painters exhibit. So if you have this sort of a solution, a weak entity in the middle between these two, if you think multiple relations, so that obviously means a painter, one painting can have multiple artists or painters involved in it, right? But this is not what they need, right? This is not they need. They need one to many kind of relationship, not many to many kind of relationship, right? So in this case, don't think about this sort of solution. This is actually wrong in this circumstance. This is okay, but this implies that multiple painters can involve in a one painting, right? So there can be a lot of errors if we implement this, because the users can make an errors. Then we need to put a lot of constraints to check that, right? So that's another thing you need to think about before. So this is not obviously a better solution for this scenario. I would say this one is the best solution, and the same applies into the gallery as well. So you can say someone can say, okay, we have the galleries. Gallery is a strong entity, and that gallery can exhibit multiple paintings, so we can have many-to-many relationship, and then we can have weak entity here as well, right? And then obviously that is also not true, because it says exclusively one painting is exclusively maintained or exhibited in one gallery, right? So if you have weak entity in the middle, that obviously means one painting can exhibit in multiple galleries, right? So this is not a true in this scenario, right? So obviously I would say this solution probably mostly not a best solution to represent this scenario, right? So this is the best one. Okay. So likewise, you need to actually think about when you have we need to question, right? So this is a solution. So the question is asking what are the what tables you would create. So these are the tables: painter table, painting table, and the gallery table. and then it asks what are the components would be, and then you can actually tell what are the components. Painter table, we may have painter ID or painter number, painter's last name, painter's first name, initials, contact details, etc., etc. And then the primary key is the paint ID, and then the painting entity, we can have the other details like painting title, right? Painting ID, painting title, and then the materials used, etc., etc. So painting ID is the primary key, and also it sits. There are two foreign keys here as well: paint ID plus gallery ID as well. And then finally, the gallery has other attributes as well along with the gallery ID. Maybe we can have gallery name, gallery's website, web address, right, gallery manager's name, right, contact details of the gallery. All these information can be recorded inside the gallery table, right? These are the components, right? And the second question is asking how might the independent tables be related to one another. Probably you can actually, in this question, in this kind of question, you can actually design this and then show as an ERD solution. That's actually probably enough for this answer. Okay, and make sure that you put the relationship names. Painted exhibit, galleries exhibit many paintings, painters can design many paintings. Don't underline, make sure don't underline, right, because these are the strong entities. Okay, right, so that's the answer to question number 9. Any questions? Any questions so far? No? All right. If that is the case, we can jump to question, Philip. Okay. How are you going, Philip? Are you sleepy? That's the time there. I think obviously it's a very early morning, isn't it? Okay. Yeah, so Ali, please rewatch, okay? Rewatch. Yeah, I'm recording. Okay, guys. Now let's see if I have plenty of coffee. Okay, so good. Okay. I haven't had my lunch, so after this class I'll have my lunch coffee. I love coffee too. Yeah, that's good. 3 a.m. my gosh. So let's actually go through this ERD diagram there. All right, so let's go through this one. So another case study, looks like a bit complicated one. So what they're asking us to do, actually they ask us to do develop a fully developed cross-foot ERD, right? Now remember in your test, next week test, you need to design the ERD plus you need to provide a relational schema. You know relational schema, we did the relational schema. First we describe the strong entities and then we describe the weak entities, relational schema, and then tell what is the primary key or other foreign key, right? So you need to do that, okay? So, but in these cases, I just only designing it to show the answer. Right, now let's go through this question again. I'll make a new page. So I don't want to save it. No, I don't want. Okay, so let's go through this. So United Helpers is a not-for-profit organization that provides aid to people after natural disasters. Based on the following brief description of the operations, create the appropriate fully labeled cross-foot ERD. So cross-foot ERD is what we are the only use, right? That is the convention we are using, cross-foot ERD or cross-foot symbols. Right, now let's go through the. Now first thing first, remember when you create the ERD, you need to go through the steps, right? So there are 9 steps, something like that. Tarin, yes, that's right. So in the test, you need to make the ERD plus you need to write the relational schema. That will take time. So make sure that you represent your table relational schema or your ERD relational schema. Okay. So that's what you need to do. Okay. Right. So your relational schema, you can type it there, obviously, or maybe what you can do is you can copy and paste the diagram into a Word document, and then you can write the relational schema inside the Word document. That's okay. You don't need to use Notepad or something, anything. Just write the use the Word document and save it. Maybe you can save it as a PDF file if possible. And then, because if you don't save it as a PDF sometimes, or maybe you can submit it as a Word document. That's perfectly okay, because I don't want part of the ERD disappear in your PDF file, right? So make sure you cross check before you submit. Now remember that, check your file before submit. I don't want, when I start marking, if I get a different file, I don't want to send an email, because it obviously not suitable, because in a testing environment you're supposed to cross check before you update or upload your file. Make sure you upload the correct file, guys, right? So I can't send an email saying, okay, please, I can't, and see whether you can open the file as well. Okay, that's something. Otherwise I need to change. It's a bit cumbersome, and university is not actually they are very strict on these matters, okay, assessment matters, especially online, because sometimes some people just submit something and they say, oh sorry, I forgot to send the correct file, and the university is asking us, okay, 0, because that's the instructions, right? The assessment. Okay, it's not like an assignment, take home assignment. This is a test, right? So make sure you cross check, double check 2 times, 3 times before you upload the file. Okay, all right. Okay, now let's go through this question. Okay, United Helpers is a not-for-profit organization that provides an aid to the people after natural disasters, right? Based on the following brief description of the operations, create the appropriate fully labeled crews for DRD. Okay, so let's go through this narrative. By the way, United Helpers, do we need any entity to represent United Helpers? Or no, I don't think so. Right? That's the company we are trying to implement the this database solution. So we obviously don't need a entity to represent that, right? Okay, right. So that's obviously we don't need that. Okay, now let's jump to the first point. Let's go to the first. Now let's go. Actually, it's organized point by point. It's easier for us. So let's go to the first point. Okay. So individual volunteers, their time to carry out the tasks of the organization. For each volunteer, their name, address, phone numbers are tracked. Okay, now they're talking about the volunteer. That's obviously a kind of an object we are interested in, right? Because they are talking about volunteer names. They want to track the volunteer details, right? Volunteer, they have names, addresses, phone numbers are tracked, right? So that means we need to take that information. That means obviously we can actually design an entity for the volunteer. So let's actually capture that first. So this is my volunteer entity, volunteer entity. So let's capture the attributes as well. So the volunteers have names, they have addresses, and the phone numbers, right? So I just put let's capture the information. So I just put the phone first actually. So phone, and then their name. Now so name is a composite, probably composite attribute, right? Remember, it can have first name, last name, middle name, initial, etc., etc. So we don't mind it. It looks like a composite. So let's keep it as is. And then we have the address. Yeah, address looks like a pretty much a strong entity, isn't it? Each volunteer has a different phone. So let's actually let me take the phone number as ID. So volunteer phone number. Actually, it's not a very good ID, right? We may have actually come up with the volunteer ID or something like that. But for the time being, let's assume phone number, because sometimes in other paragraphs they may have talking about IDs or something. Then we need to get rid of this and make volunteer ID. Okay. Right. Right now let's go. Okay, track. Each volunteer may be assigned to several tasks, right, during the time that they are doing the volunteer work. And some tasks require many volunteers, and it is possible for a volunteer to be in the system without having been assigned to a task yet, right? So the volunteers are going to assign to the tasks, right? So volunteers actually assigned to multiple tasks, right? So one volunteer can assign to multiple tasks, and looks like a task can have multiple volunteers. So it looks like a kind of a many-to-many relationship exists, right, between the volunteer and then probably there may be another entity called the task. Let's see. Okay. It is possible that to have the task that no one has been assigned. When a volunteer is assigned to a task, the system should track the start time and the end time of the assignment. All right. Okay. So if the volunteers assigned to a tasks, right? Uh, so that means one volunteer can assign multiple, one task can have multiple. So we can have a kind of a weak entity in the middle, right? That's where we show which volunteer assigned to which task and what is the time each task takes. So what is the starting time, what is the ending time, and then we can say we can derive the time that they have spent on a particular task, right? So that's obvious in this. Now, if you read that, that's what it looks like, right? So let's read the next paragraph and then try to capture. For each task, there is a task arc, right? Now, here they are talking about tasks. Each task, there is a task code, task description, task type, and the task state. Right now, looks like a task is a pretty much a strong entry. Here you go. So let's capture that. Okay, so we have the task. Okay, so this is my task entity. So let's actually clarify that first. So task entity, and it contains a bunch of attributes. What are the attributes we have? A task code, task description, task type, and task status, right? So these are the four attributes. Now let's write that actually first. So this is task code, and then we have task description. So I just put TD, okay, task description is a task description, and then we have task type. So I will just put task, okay, just task type, and then final one is task status. So I just put status here. So obviously task code looks like a primary key. So that means now we have this link, right? One volunteer can assign to multiple tasks. One task can be assigned to multiple volunteers. So so that means obviously we can expect a weak entity in the middle, isn't it? So what is this weak entity actually represents? What is this representing? Is representing the assignment, right? Isn't it? Which volunteer assigned to which task, right? Isn't it? It looks like that. So let's put that. Let's name this as an assignment. And then it obviously it says in the first paragraph they wanted to capture the start time and the end time of the assignment, right? So that means there are two attributes here. Additional two attributes: start time and the end time. Okay, so I just put start t and this end t. So end t. Okay, so there is a relationship between here, right? So obviously the many-to-many relationship we broken down into two one-to-many relationships, right? One-to-many, one-to-many. And then let's think about the participation or the participation constraints. So what it says is the volunteers. So there can be volunteers that not assigned to any assignments, right? But still we have volunteer list there. So that means one volunteer may have assigned to 0 or many assignments. But obviously if you have an assigned volunteer, it must belongs to one volunteer. And then here in the same applies to here. We may have let me check. Let's check, because which is not clear for here the task. So let's read the second one. to capture the cardinality constraints or the participation constraint. For each task, there is a task code, task description, task type, and task status. For example, there may be a task with the task code 101, description of answer the phone, the type of recurring, and the status of ongoing. There could be another task with code 102, a description of prepare 5,000 packages of basic medical supplies. The type of packing, type is packing, and the status of open. Okay, but it's still not so clear here. So let's actually jump to the next one. For all the task type, okay, now they're talking about something else. But here, let's assume here one task, or there can be a task that we are not assigned. Okay, that's actually obvious as well, because we can have tasks without assigning. So one task may have many assignments, so that's possible. We don't have it. But if you have an assigned task, it must belong to one task. Okay, so what is the primary key for the assignment, guys? So that means we need to borrow the task code and the phone number. So that's the primary key, or composite primary key of the assignment, right? So we can say here a task is, or the volunteer is assigned, that is assigned relationship. So underline that relationship, so that means we are borrowing the primary key to this end, and here tasks has some assignments. So we can just put task. So we can underline that as well to indicate it borrows the task code, right? So that's what actually the first two points are talking about, this small model, isn't it? This small model. Okay. So let's move to the third point. Probably we may get some more information. For all the tasks of type packing, there is a packing list that specifies the contents of the packages. There's a packing list that specifies the contents of the packages. Okay, so for all the tasks, so the task can have, that means the lists, right? Some kind of a list. That's what it says. It actually describes the contents of the packages they are trying to distribute, right? That's what it looks like. So there are many different packing lists to be produced for different packages, such as basic medical packages, childcare packages, food packages, etc., etc. Each packing list has a packing list ID number, packing list name, and packing list description, which describe okay, packaging name. Okay, looks like a packing list. It looks like another entity. Looks like a strong entity, right? This time, because each packing list has an ID number. So let's actually capture that one first, and let's see how it's going to relate with this model. Let me put that here. So this is my let me make it as a list. So that is my list entity. So list entity packing list has a packing list ID number, list name, and a list description. Okay, so that's the list attribute. So let's actually capture that. So there are 3 attributes: list ID, list name, and the description of the list, right? So let's capture list. So I just put LID, this is the list ID, that's the primary key, so I will underline that. And then I have a list name, so L name, and then I have a description, list description. Okay. So a packing list may or may not be associated with any task. Now this line, when you read that particular sentence, looks like there is a relationship between the list and the task, right? That's the relationship comes in, right? Isn't it? So a packing list may or may not be associated with any tasks, right? So that means one packing list may be associated with zero or many tasks. That's what you mean by that, right? Okay, so there can be some lists not associated with any task as well. So one list can associate with multiple tasks. So that means we can have tasks, and then let's see what we have to do in this side with respect to cardinality constraint. Um, every packing list associated with only one, sorry, every packing task is associated with only one task, or only one task associated with one packing list. Yes, that's obvious. That's what we have put in here. uh, a packing list may not be associated with any task, or may be associated with multiple tasks. Oh, yes, that's what we left to right to left indicate, right? Zero or many. Tasks that are not packing tasks are not associated with any packing list. So there are some tasks, obviously it is a list here, like I think the phone calls or something like that. Getting phone calls is a task, but it's not actually associated with any lists items or lists here. So that means right to left, sorry, left to right, it's may. So one task may associated with one list. Okay, right, so that's constraint. I just put it there, so I can actually now name the relationship. Maybe you can say one list used by, or one task used by many lists. So one list used many lists. I can just put used by. So don't underline because it's a strong hint. We are not borrowing anything, but here list ID goes there as a foreign key. That's what it happens, right? Right. So I think that's we done that part. Now we can come to the next one here. Packing task results in the creation of packages. Okay, packing task results on creation of. Okay, packing task results on creation of kind of a package. We don't know what is that is. So let's read it. Each individual package of supplies that produced by the organization is tracked. So package need to be tracked. Okay, so that means obviously if you want to track something, you need to record, you need to have a record in our database. So the package details need to be tracked. Okay, so looks like another entity comes into play, like a kind of, I would say, a package details, right? So let's actually, looks like now, so I just capture it straight away. Let's say a package, right? So okay, so just give me 1 second. It will come. It's going through. Okay, back. So the packing task results in creation of packages. So there is a relationship between the packing tasks and the packages. Yes. Okay, so tasks create packages. That's what it looks like. Um, uh, and this individual package of supplies that produced by the organization is tracked. Yes, we captured it. Each package is assigned an ID number. How? Each package is assigned an ID number. Looks like a strong entity, right? Isn't it? So there's ID number. The date of the package created. Yes, the date created need to be captured, and the total weight of the package is recorded as well. So total weight is recorded. So looks like there's three attributes: package ID, date created, the package, and the weight of the package. So these are the obviously an attribute we need to, or the facts that we need to capture. So let's capture that one first. So I have PID, that's the package ID, that's my primary key. And then I need to capture the date creation or creation date, and then I need to capture the weight, sorry, uh, weight. So somebody's calling me, sorry. The weight, right? So these are the three attributes. I need to capture. Okay, so let's go through the date. Blah, 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 blah. Correct. So a given package is associated with only one task. Okay, so given package is associated with only one task. Okay, one and only one task. Okay. Um, um, some task, example answering the phones, will not have produce any packages, while the other tasks, right, example prepare 5,000 packages of basic medical supplies, will be associated with many packages. So looks like, okay, one task may have one zero or many packages, right? Isn't it? That's what it means, right? So now we captured the cardinalities. Cardinality and constraints as well, or the participation constraints. So we can say here, okay, so one task creates zero or many packages. So I just write the relationship name as creates. Okay, yeah, that's what it means, right? So that's relationship. And then the next one, the packing list describe the ideal contents of each package. The packing lists describe, so right, so they're coming revisiting here again. A packing list describe the ideal contents of the package. Okay, this list actually describe what the contents in the here, right? But it is not always possible to include the ideal number of each item. Okay, so therefore each actual item included in each package should be tracked. Okay, so that means if the package maybe consists package says, okay, this particular package, release package, contains 2 liters of water, or 4 liters of some sort of a medical sort of some component or some medical supplies, right? Of four. So these 2 liters or 2 liters water maybe come up with a different ways, right? You can have 1 liter 2 bottles, right? Or 4 liter or 4 bottles with 500 milliliters, right? Or 8 bottles with 250 milliliters, right? So that is what we mean by this, right? So each contents uh, uh, actually not described here, but we need to actually capture that contents, exact contents of this list. If it is 2 liter bottles, or sorry, 2 liters of water, what is the contents of 2 liter, how it composed of. It is a 2 liter, 1 liter each bottle, 2 bottles, or 250 milliliter 8 bottles, or something like that, right? So that's what it says. They need to capture the ideal number of each item, ideal number of each item. Therefore, the actual items included in each package should be tracked. Okay, so we need to track the actual items in this package. A package can contain many different items, and the given item can be used in many different packages. Now looks like there is another entity lurking somewhere here, or maybe here, right? So we may have the items, right? That is the items. That items actually describe the contents of the package, right? So maybe I can actually capture that. I can say, okay, I have the items. So we don't know what are the attributes of the item. Looks like that. So I just obviously capture that. So items can have. So if you think about 500 milliliter bottles, can be obviously contains in the multiple packages, right? So one package can contains multiple 500 milliliter bottles, right? So that means looks like there is a many-to-many relationship between the items, one single item and the package. So that means we need to actually, this is where we have that weak entity where it captures the contents of that package, right? If we have a 2 liter water bottle in that list, in that particular package, right? how the composition looks like. That actually described in this entity, right? The weak entity in this middle, right? That's what it looks like, right? That's what it looks like. So because there is a man-to-man relationship between these two. Okay, now let's go to, I think that's described in the next sentence or next paragraph. The packing list describe the ideal contains of each package, but it's not always possible to include the ideal number of each item. Therefore, the actual items included in each package should be tracked. A package can contain many different items, and given items can be used in many different packages. So we already done that. So that's what we have created here. So let's go to the next one. I will just go to the next one. Each item in that organization provide. Okay, so each item that the organization provide has an item ID number, item description, item value, and the item quantity on hand stored in the system. Okay, so that means they are actually describing the attributes of the item. So let's capture that, those attributes. So what are the attributes? We have item ID, item ID, item description, item value, item description, item value, and then the other one is quantity, yeah, item quantity in hand. Okay, so that is a quantity. So there are 4 attributes belong to the items. So let's capture that. So item ID, and then we have item description, and then we have the value of the item, right? ID is the dollar value of the item, and then we have the quantity at the store, how many quantities we have, right? So I can underline that. Okay, so let's read that. Each item that along with the tracking the actual items that are placed in each package, the quantity of each item placed in the package must be tracked as well. Okay, so as I mentioned before, if you if the list says there for 2 liters of water, so we need to think about, okay, how many bottles of 500 milliliter. So 500 means 500. 500 milliliter bottles has to be there, right? So that quantity has to be recorded somewhere. Probably it may come in the weak entity in the middle, right? That is where we record the quantity of package items, right? Now this quantity is the quantity in hand, right, in the stores, right? So we can actually expand the many-to-many relationship here. So let's design that weak entity. So we can actually let's give a name for this. Yeah, this is actually the contents, I would say, right? This is the contents or the package items, right? We can say package items or the contents, right? So we have now 2 one-to-many relationships there. Okay, so the quantity on the package now we can record there. Okay, this is the quantity, package quantity. Package quantity. Okay, what is the identifier for the contents? Item ID, right, and the package ID, right? So that means we need to borrow identifiers from the both then. So that means let's name the relationship. So let's say items has the contents and package has the contents. So that means I need to underline the relationships to indicate that we are borrowing the identifiers. Right, so that means now what it says, now let's go through it and see whether how you put the participation constraints there. So each item that the organization provides has an item ID number, item description, item value, and item quantity on hand at the store, along with the packaging, tracking of actual items that are placed in each package. The quantity of each item placed in the package must be tracked as well. Yes, we recorded that. For example, a packing list may state the basic medical packages should include 100 bandages, 4 bottles of iodine, and 4 bottles of hydrogen peroxide. However, because the limited supply of items, given package may include only 10 bandages, 1 bottle of iodine, and no hydrogen peroxide. The fact that this package includes the bandages and iodine needs to be recorded along with the quantity of each items included. It is possible for an organization to have items that have not been included in any package. Now it's give a clue. We can have the items but not been included in this package. That means not really included in the content. So that means this is may. So one item may be included in 0 many times or in the contents. That's what it says, isn't it? It is possible for the organization to have the items that have not been included in any package yet. Any package yet, yes, that's what it says. And then what else? The package, but every package will contain at least 1 items, right? So each package must contain at least one item. So each package must contain one or many contents, but that content must belongs to one package, and also one content must, if there is a one content, it must belong to the item listed in our item database, right? That's it looks like, right? So, yeah, I think that's yeah. This is the final diagram. This is the final ERD. Yeah, this is the final ERD. So what they ask us to do is the ERD, right? So here 1, 2, 3, 4, 5, 6, 7, 7 entities are there, right? 7 entities are there. Sometimes maybe think, okay, can we put a kind of a link between the list and the items? Sometimes you may think, okay, because each list, actually this describe the items in the package. Sometimes you may think, okay, do we need the link? Obviously not. We don't need that link, because this company or the users of this particular package or this database not interested in that. They haven't actually mentioned that they wanted to track the listed items in the item list, right? So they are obviously not interested in that. So we don't need to have an unnecessary link between the list and the items, or even the list and the packages, because the list and package obviously come through this link, right? So we don't need to have another link between these two, because it's assumed we can come through this path, right? This path. Okay. So this is the answer. Now, if you get a kind of this kind of a question, probably not this much of hard. Then you design this, you copy and paste this into a Word document, right? So you can copy this like this. So it's very clear. There's no issue, no questions. So you can go to the Word document. Okay, Word, where's the Word. Let's take the Word document. Let's open the Word document. I just showing you how to do the answer. And then maybe you can lay out orientation, landscape, and then you can paste the document. Yeah, that's the answer. And then you can write, okay, relational schema. Okay, and then you can start write the relational schema. How to write relational schema? First you write the strong entities. You can start with volunteer. So volunteer, you can just list phone, comma, the name, comma, the address, right? And then close the brackets. So you can say primary key. Just list PK, that's fine. PK is the phone. Okay, that's it. And then you can go to the task. You can't go to the task because there's a foreign key comes there. Maybe you can go to the list. Okay, list. Okay, so list ID, list name, and list description. Okay, list description. So let's just make it bit bigger. Oops, cancel. Bigger. This description, and then you can say the primary key for this is list ID, right? Okay, and then we can come to probably the task code, task description, task type, status, and the foreign key, right? Remember, there's a foreign key. List ID comes there, right? So, and then you can say primary key is task code, and we have the foreign key. It's a foreign key list ID, right? References list. So likewise, you can actually populate. You can just write by based on your EID, and then make sure. And then one more thing. Is maybe obviously you can actually as a maybe you can put a footnote, or maybe insert. Maybe you can do that actually first before you do maybe header. You just put a header, and then put a header. Just write your name, right? Maybe you can header or whatever the footer. You just write your name, Ravinder Sinha, and ID 11738567 or something like that. That's a student ID, right? And then this very clear. You can see the answer is very clear. So just once you put all the list, answer is very clear. Or maybe you can say double check it. Maybe if you want to make it PDF, save it as a PDF, right? Save it as a PDF, and then maybe you can save it on the desktop, and then submit the PDF file, and check the PDF file also. Okay, and then you can double check it whether your saved file is correctly working. So what I do is save it. So let's save it, and then I'll go to my desktop and see whether I have a okay, so do I have that? Save it and double check whether you have that relational schema somewhere here. So anyway, just double check it before you submit anything, okay? Or maybe you can actually submit the same Word file as well. And yeah, so that's how you're going to answer the final question. Okay.